M1 Dynamics example 8. In this example, we've got a block of mass 5 kilograms, which is at rest on rough horizontal ground. So if we label the forces, that's 5G for the weight, and we need a normal reaction on our diagram as well. The coefficient of friction is 0.4, that's mu. A horizontal force P is applied to the block. So if that was going to pull it forwards, then we would have our frictional force acting in the opposite direction. Find the magnitude of the friction force acting on the block and the acceleration when P is 10. Well, let's have a look first of all at what's going on. We need to know the size of this frictional force, and we know that that will have its maximum value at mu r. Looking vertically, we can see that r is equal to 5g because there's no motion vertically, and so we'll have 0.4 multiplied by 5g, and if we work that out, that works out to be 19.6 newtons. So that is the maximum frictional force we could have. So if P is 10, that means we've got a forward force of 10 and a frictional force that could be up to 19.6 newtons. So what would happen? Well, this force would try and pull the box along, but there's sufficient friction to stop it from happening. So the frictional force in this case would only need to be 10 newtons. Remember, 19.6 is the maximum the friction can get to. And the acceleration would be 0 because the object wouldn't move. When we get to PB 19.6, we're in a situation that we call limiting equilibrium. Equilibrium is when a particle is either stationary or moving at a constant speed and the forces on it are balanced. Now in this case we've got 19.6 newtons acting forward and we've reached our maximum value of friction, so 19.6 acting backwards as well. They balance each other out, so the object would still stay stationary, it wouldn't accelerate, but it's just on the point of moving. And that comes up quite a lot in exam questions where we talk about an object that's on the point of motion, and that's what we mean by limiting equilibrium. In the third example, P is 30 newtons. The forward force overcomes the maximum value of friction. So if we were to do F equals ma, forwards, we'd have P minus F equals the mass times the acceleration, which is what we're trying to find. Now P is 30, the maximum value of friction will have been reached and overcome, and that will equal 5a. And doing the calculations there, A works out to be 2.1 meters per second squared, and the frictional value is 19.6. Once an object starts to move, it's at its maximum value of friction.